What's up, everybody? This is Mr. Tui, creator of the SAT Crash Course series. And if you're looking for an SAT math review, I got you covered. In this video, we're going to review one of the most commonly tested concepts on the SAT math section, functions. And I'm going to teach you how to solve all the questions that appear in this video the simplest way possible, with an emphasis on math concepts, not just complex step-by-step operations. Oh, and by the way, if you like this video, you definitely want to access the full version of the SAT Crash Course series. Just click the link in the description below to access the full version of the course. In the meantime, sit back, relax, and enjoy this SAT math review.
We got a function question here. Question number 2. Before we do the functions, let's go to the rules for mathing on functions. And so what kind of the plan for this course, guys? You know, we in level 1 we talked about the basic strategies and approaches to the questions and the kind of stuff that's going to give you that initial boost in your score. This course is designed for maybe some of the more specific kinds of concepts that you're going to be tested on. The level of difficulty of questions is going to be a little bit higher, but I promise you I'm going to teach you kind of the simplest way possible, and it's going to be explained in ways that y'all can understand, no problem. So let's start with, we need to read the rules for functions, that first bullet point. So Nicole, will you read that for me loud and proud, please? Do you see that on the screen? It says functions, and then the first bullet point, understand x is the input. Go ahead and read that for me, please.
Understand x is the input, fx is the output.
Yeah, I'm going to stop you real quick. I just want you to be aware of how that's read f of x. And I clarify that, not to be too picky, but just because a lot of students think that means f times x, right? Because normally if those were just two variables, and we're not talking about functions, right, that would mean f times x. It's true. It's what it looks like. But when we're talking about functions, this is called function notation, and that means f of x. That's the output of a function. So x is the input, f of x is the output. Go ahead and finish that off, please.
Okay. Also understand f of x as fancy y. They are interchangeable when graphing on an xy axis.
Yeah, that means basically if you find f of x equals 7, for example, that pops up either on a chart or that's something you calculate, then that means you can plot that point on an xy axis for the point for the value of 7 for y on the xy axis. So anytime you see some f of x value, again that's like a y on the xy axis. So let's go to the question here. Nicole, read that for me. Question number 2, please.
Some values of the linear function f are shown in the table above. Which of the following defines f?
Which of the following defines f? And again, f is the function, right? So we've got 4 answer choices here, 4 potential functions, like equations, right, for the function f. Okay? Let's go over functions again real quick and kind of how they work and what I mean by x is the input, f of x is the output. I'm gonna give you another function not directly related to this. We'll say f of x equals 2x plus 1. Okay? If f of x is 2x plus 1, and I say x is 1, right? So 1 is the input. I would describe that as this, f of 1. Because where there was an x, now there's a 1. Does that make sense, guys? Yes or no? Does that make sense?
Yeah. Yes.
At this point? Okay. And I think, again, we've gone over this at some point before, I think, the level 1 course, but I want to review it. So now, where there was an x, now there's a 1. That means we're plugging in that 1 where there was an x. So what does f of 1 equal? Guys, what does f of 1 equal?
3.
Yeah, f of 1 is 3. Does that make sense?
Yeah.
Okay, no questions. Okay, good. Okay, so let's go to the question. Clear this. All right. So which of the following defines f? Nicole, how could we find out which is the correct function of f given this sets of values, these inputs and outputs? How could we test this?
You could just start plugging in values.
Yeah, and what would we plug in for x to start?
1.
Plug in a 1 for x, right? And then what should the output be when x is 1? What should the output be?
5.
The output should be 5. Does that make sense, guys?
Yeah.
Yeah? X is the input, f of x is the output. So when x is 1, f of x is 5. Okay, so let's test these. Let's plug these in. Let's start with answer choice A. Can I see you, Nicole, on the whiteboard? Can I see you plug in 1 for x? Let's see what we get for f of x.
Oh, sure. Okay. Can you see that?
Yep, I got you.
Okay. Oh.
Perfect. Good. And just so you're aware of like how function notation works again, we could say, we've got the calculation is absolutely perfect, but we could say f of 1 equals 5. Right? And again, x is the input, so when x is 1, the output equals 5. Does that make sense, guys?
Yeah.
Okay. So far, answer choice A works. I don't want to eliminate it. Let's try answer choice B. Just find a spot on the whiteboard and see if we can calculate that. So let's see. Good. Okay. So for answer choice B, f of 1 also equals 5. Can we eliminate it? Keep it? What do we do with that?
Keep it for now.
Keep it, right? Because, yeah, I mean, according to the chart, f of 1 does equal 5, so that's good. I'm looking at the other answers. I'm looking at C and D. And I think I know what f of 1 is going to be for C and D. What's f of 1 going to be for C and D? Nicole?
5.
It's going to be 5 for those as well. Does that make sense, guys? For C and D, f of 1 is going to be 5?
Yeah.
Yeah.
Okay, great. We're all on the same page? Okay. So, and we could go through it. I don't want to spend the time on it right now, again, if this is already familiar. But I just want to, again, reinforce the concept of inputs and outputs. Let's try another value for x, and I think this is going to help us determine what the right answer choice is. Let's try 3 for x now. Let's try that 3. And what is the output going to be for the correct answer choice? Nicole, what's the output going to be?
13.
It's going to be 13. We know that, right? Okay. So let's do that. Let's plug in, and I'll clear some space here on the whiteboard. Let's plug in a 3 for x into the answer choices, and the correct answer choice should give us 13. All right. What's up, Hudson? Can you hear me, buddy? All right, welcome. Go ahead. I can't hear you. I think you got to turn your microphone on. If you get that set up. Oh, there we go. Good, good. Welcome, buddy. So we're in the middle of a question right now on functions. Just do your best to follow along. All right. So let's plug in a 3 now into the answer choice. We'll start with answer choice A. Can you do that, Nicole? So what's f of 3 for answer choice A?
Did you want me to do that one?
Yeah, please.
Okay.
Okay, looking good. This is perfect. 6 plus 3, is that going to give us 13? Not so much, right? And we know the correct answer choice has to give us 13, right? So we can eliminate answer choice A. Does that make sense? Nicole, does that make sense?
Yep.
Everybody else, does that make sense why we can eliminate A?
Yes.
We know when x is 3, we need to get 13. That's not what we get here. Let's try answer choice B.
All right.
We're getting closer. That's 11. We need 13, right? Not 11, right? So we can also eliminate answer choice B. Let's try answer choice C. Let's test that. That's looking good. Excellent. Okay, so let's keep C. I don't want to eliminate it. Let's try answer choice D, but I bet we can kind of figure that out mentally, right? Is D going to give us 13?
No.
No, it's going to give us 15. So we can eliminate D. It is indeed answer choice C. Any questions about question number 2? No questions?
Nope.
We're good? Okay. Now, again, if you took the level 1 course, this may be, you may be familiar with this already. You may be familiar with this already just in general. But I can't emphasize it enough because it's one of the most commonly tested concepts is functions. You're going to see probably 6 or 7 questions related to functions on every SAT math section. You've got to know it. And you've got to understand it in terms of inputs and outputs. And if you've got that down, you're going to be good on most of the questions. And then we need this concept of inputs and outputs to do some of the higher level function questions as well. So that's why we're reviewing it. All right, let me clear the whiteboard and I'll put the next question up. Right, let's do the next one. All right, and we are at Ava, I believe. It is your turn. Go on and read question number 34 for me, please.
In the xy plane, the point 2, 5 lies in the graph of the function f. If f of x equals k minus x squared, where k is a constant, what is the value of k?
Okay, Ava, how can we use our understanding of like inputs and outputs and f of x as fancy y? How can we use that to answer this question?
So 2 is the x coordinate.
Absolutely. Yep, 2 is the x value.
So we could see what k is when x is 2.
What an x is 2. And then what do we do with that 5 here? Right? That's the y value.
So we can substitute that for f of x.
Absolutely, right? Because f of x is just fancy y, right? Does that make sense?
Yes.
Nicole, does that make sense?
Yes.
Okay, excellent. All right, so let me see you do that, Ava. Go ahead and plug in, we're going to rewrite the function. Let's plug in 5 for f of x, because that's the y value, and plug in 2 for x, and then we're solving for k.
I don't have the whiteboard.
Oh, you don't have access to that?
I'm using my dad's laptop.
Okay, no problem. Let's, let me write it out. So, because anyway, it's just what we described, right? So we've got 5 equals, and then k, we still don't know what k is. K minus x squared, but what's the x value again, guys? What's the x value?
2.
2, right? So 2 squared. Okay? So 5 equals k minus 4. And we could do some algebra here, an operation. I'll bet just logically we could figure out what k is. Just logically, what's k going to have to be?
9?
K's going to have to be 9, right? Does that make sense, guys, why k is 9?
Yeah.
Right? Some value minus 4 is going to give you 5. That's going to have to be 9. And, the operation, of course, you add 4 to both sides. It's not too complicated. But we can confirm it sort of with logic. K is 9, and that's the answer. Is that difficult?
No, that's not difficult.
Not at all, right? If you understand the relationship between inputs and outputs in functions, and x is the input, and f of x is the output, and f of x is fancy y, you're going to nail this question. It's easy. And this is at the end of section 4, the hardest part of the test. Very few kids are going to get this, because most people don't understand the relationships between inputs and outputs in functions. But you do. Okay? Questions about that one or no? No?
No.
We're good? All right. Let's roll. Okay. This one's a little bit different. Okay, we're going to bump up the level of difficulty here. Okay? This is one, even if you did the level 1 course, you've not seen one quite like this. But again, it's still inputs and outputs. That hasn't changed. Hannah, can you read this one for me, please?
Yes. If f of x equals negative 2x plus 5, what is f of negative 3x?
Okay. Now, don't freak out here. Don't freak out. All right? I know this part's a little bit like, oh, what do I do with that? But it's still inputs and outputs, right? So, because of function notation, right, the thing in parentheses is the input. What's the input into this function? Hannah?
Negative 3x.
Negative 3x is the input, right? So where there was an x, now there's going to be a negative 3x. So we're plugging in negative 3x for x. Does that make sense?
Yes.
Okay, it's a little bit weird. I know you're like, what x is the input? Well, here, because of function notation, the thing in parentheses is the input. The input is negative 3x. So can I see you rewrite this function with negative 3x as the input? Can I see you do that?
Okay.
Okay. So plug in negative 3x for x.
Can you see that?
Yep. Doing great.
Oops.
Well, I'm going to stop you real quick. Hold on just a second. Hold on. So remember, what are we substituting for? What are we substituting for x?
Negative 3x.
Negative 3x. So there's no need to write x, right? Let me. I'll erase that for you.
Okay.
There you go.
Thanks.
You're welcome. Okay, now stop just a minute. Everybody take a look at this. Does it make sense what she's done? Yes or no?
Yes.
Yes.
Yeah?
Yeah.
We're good? Okay. All right, so again, where there was an x, now we've just plugged in a negative 3x. It's the exact same thing we would do if it said, what is f of 2? Right? If it said, what's f of 2? All we're doing is just, where there was an x, now we're plugging in a 2. So it would be negative 2 times 2 plus 5, right? But instead of it being a negative 2, it's just negative 3x. That's the input. Okay? Looks scarier, but it's the exact same principle. Does it make sense why it's the exact same principle? Does that make sense?
Yeah.
Yeah?
Yep.
Okay, great. All right. Now, how do we calculate this, Hannah?
You would just simplify it.
Yeah, just simplify it, combine like terms. So what's negative 2 times negative 3x? What's that going to be?
6x.
6x. Okay. That's going to be 6x. Does it make sense why that's 6x right there, guys? Remember, a negative times a negative is a positive. Does that make sense why that's 6x? Yes or no?
Yep.
We're good there? Any questions about that?
No.
No? Okay. So that's 6x, and then plus 5 is the same. Can I combine those or no, guys? 6x
No.
plus 5? I can't do anything with that, right? Because I don't have like terms. Right? I've got an x in here, and there's no variable there. So that's it. What's the answer?
B.
Speak. Any questions?
No.
Okay. It's still inputs and outputs. And x is still the input, and f of x is still the output. Hasn't changed. Okay. Good. Let's do the next guy. I think it's this guy. Right? Yeah. Woo! This one looks scary. Looks scary. Owen, you lucky man, you get to do this one. Go ahead and read question number 30 for me, please, Owen.
The complete graph of the function f and a table of values for the function g are shown above. The maximum value of f is k. What is the value of g of k?
Okay. Let's break it down. This is a lot scarier looking than it is. Okay? Especially if you understand functions. Question says the maximum value of f, right, which is it's the function in the graph. The maximum value of f is k. Well, what's the maximum value of f?
3.
3, right? You guys see it?
Yep.
It's the highest value of f, right there. It's 3. Any questions about that, yes or no?
No.
No? We're good? All right. So, we know that k is 3. Let's start there. This is so easy. This is so easy. What do we do from here, Owen? Can you tell me what we do from this point?
Find g of 3.
Find g of 3. Right? That's all we're doing, right? What is the value of g of k? And k is 3. We're finding g of 3. That's it. And what's g of 3?
0.
That is a very reasonable guess. But that's not quite correct. Remember, this says g of 3. X is the input.
Oh, so is it 6?
It would be 6. G of 3 is 6. G of 3 is 6. Where X is the input, right? Because that would be where X is the input. And when 3 is the input, 6 is the output. Does that make sense? Yes or no?
Yeah.
That's a little bit tricky. Maybe it wasn't actually. It wasn't quite as easy as I led on. If you understand, right, that X is the input and G of X is the output, you got to have that. Don't lose sight of that. Questions about that, guys?
No, I think I got it.
Does that make sense?
Yeah.
Do you see what Hudson was? I totally get what Hudson was doing. Hudson was looking at this, right? Because he was thinking that was G of 3, but that's not G of 3 there. That would be G of 0 equals 3.
Yeah.
Does that make sense, guys? Where X is the input, or where 0 is the input, 3 would be the output. But we know 3 is the input. So that's right there. So 6 has got to be the output there. Any questions about that? No?
Nope.
Do you guys? So look again. They're testing you guys. They're testing you on concepts, not operations here. If you get the concept of a function and you get the relation between inputs and outputs, then you know what to do here. You don't have to worry about like, okay, what is the exact step I have to follow? No, don't worry about that. If you get the concept, you're going to get this one right. Does that make sense? Yeah.
Yeah.
Yep.
Good. All right. Let's go to the next. Okay. Nicole, is this all making sense?
Yep.
Yep. Okay, great. Okay. This one. A little higher level difficulty here. For this one, Hudson! Go ahead and read question number 25 for me, please.
Okay. Some values of the linear function f are shown in the table above. What is the value of f of 3?
What is the value of f of 3? What are they asking us to solve here for? Hudson?
X.
Not x.
For the value of f of 3.
Yeah, for the value of f of 3, right? The thing you're solving for is always in the last sentence of the question, right? They're asking you to solve for f of 3, which means there's some function f. We don't know what it is. We might have to find out what it is. In fact, I think we do. Okay? But for this function f, whatever it is, they're asking us, what is the value, what is the output when the input is 3, when x is 3? Does that make sense?
Mm-hmm.
Okay. That's just, again, function notation. What is the output when the input x is 3? Okay. Ooh. I think we need to know what the function is, right? Because I'm looking at the chart. If the chart told us, like what the f of x was for an x of 3, then we'd be good. And we just play matching. But we can't do that here. We don't. It doesn't tell us what the output is when the input is 3. Okay? We'd be able to figure it out if we knew what the function was. Okay? And I think they give us enough information here to figure out what the actual function is. It may not be obvious, but they do. Okay? Remember, this is a linear function. And what does that mean, linear, guys? I'll take it from anybody. Does anybody know what linear means?
A line?
It's a line. Absolutely, it's a line. So we've got a couple ways.
Increases at the same rate.
Absolutely. It's got a constant rate of change, right? So there's going to be some slope, right? And it's a line, so it's x is going to be to the power of 1, not to the power of 2. If we were to the power of 2, we'd have a parabola. It'd be a parabolic function or a quadratic function, same thing. Not a linear function. Does that make sense, guys?
Yeah.
Okay. So we got a couple options. We can kind of work this one out mathematically, or heck, we can graph this. We can graph this. That's 3 sets of ordered pairs. We can plot those lines or plot those points on an xy axis and find out what the line is. Does that make sense?
Yeah.
What do you want to do? Do you want to do it sort of mathematically, or do you want to do it graphing? Or you don't care?
Let's do graphing.
I think graphing is going to be the easiest way to do it. Okay, and it's certainly going to make it more concrete. So let's do that. Let's graph this guy. I'm going to set up an XY axis right here on the right-hand side. Okay, and then can I see you, Hudson? Can I see you plot these points on the XY axis?
Yeah.
Okay. So you're jumping. Okay, you're moving by twos. Can we go by ones? I just don't like, especially like when we're calculating slope and we're just like, let's just go by ones. Don't worry about the 16 in there. I think as long as we have 2 points, we've got a line. So let's just go by ones. I could see. Do you understand what I'm saying? I could see some mistakes arising if we're going by twos. Okay, so this is the first point. Absolutely right. This is the first point. 0, comma, negative 2. I love that you're able to figure that out right off the bat. 0, comma, negative 2. Does that make sense, guys, where we got that from? 0, comma, negative 2? Do we see that? Yes or no?
Yes.
Yeah.
Okay, no question about that, right? I mean, this is an ordered pair. 0, comma, negative 2. Remember, f of x is just fancy y. That's all it is. So we're looking good right there so far. Okay. What about the next point? Let's do the next one, 2, comma, 4. Okay. Plot it. Great. You got 2 points. You got a line. Draw that line, buddy. Great. I love it. Okay. Let's talk about y equals mx plus b form. We're going to come back to that because we're going to do some graphing today, but let's preview it a little bit, right? Every line can be expressed with the equation y equals mx plus b, where the m value is the slope and the b value is the y-intercept. Is that familiar to most of you? Y equals mx plus b form? Yes or no?
Yeah.
Yeah.
Is it not familiar to anyone? Does anyone not know what it means? We're good? If not, let me know if you got questions about it. Again, we're going to get into a little more detail on this when we get to the graphic section today, okay? But first, this is going to be easy. This is going to be easy because I think we know what the y-intercept is, right? We know what the b value is, right? What's the b value? Hudson?
3.
Nope.
Wait.
No. Remember, b is the y-intercept. Do you know what I mean when I say y-intercept? Or no?
Not completely.
No.
I haven't done that.
Remember, this is an xy axis, so that's the y-axis is the x-axis. So the y-intercept is just where the line hits the y-axis. Right?
Okay.
And where does the line hit the y-axis? Can you show me where on the graph? Where does the line hit the y-axis?
-2.
At -2. And that's the answer. B is -2. So it's y equals mx, we're going to find out what the slope is in just a minute, -2. Does that make sense so far?
Mm-hmm.
Guys, does that make sense? Why the b value is -2?
Yeah.
We're good? Okay, excellent. All right. So the b value is -2. Now we're going to find the m value, and that's the slope. Guys, what is slope? How do you calculate that?
It's the rise over run.
It's the rise over the run. The rise over the run. Is that familiar to you guys? Slope is rise over run? Yes or no?
Yes.
That's familiar? Okay. All right.
Yeah.
All right. So we go up how many and over how many here? Hudson, we just count.
Well, up by 6.
Up by
over
6.
By 2.
And over by 2, right? 1, 2, 3, 4, 5, 6. Up by 6 and over by 2. 1, 2. From this point to this point. Right? Up 6, over 2. So what's the m value? I mean, you could say 6 over 2. Can you simplify that?
3.
3. Y equals 3x minus 2. Right? There's our equation. In function notation, we would just call it f of x equals 3x minus 2. But it's the same thing. F of x is just fancy y. Same thing. Any questions about that so far?
No.
Yes? No? We're good? Okay, great.
We were just plugging the 3 for the
And then just plug in the 3 for x. What is it?
7.
Yeah. It's going to be 3 times 3, which is 9, minus 2, which is going to be 7. So we'd say f of 3 equals 7. Do we see that answer choice?
Yeah, B.
Yeah, answer choice. Oops. There we go. Answer choice B. Any questions about that?
No.
No? Okay. Now, this is a tough question. This is a very high-level difficulty question. But can you guys do this with your current skill set?
Yes.
I think so. With a little practice. Okay? A little practice. Another way to think about this would be to sort of think about it just like purely mathematically, without graphing. We could do it without graphing. And if you just recognize the fact that when x is 0, you get a negative 2 for an output. So if we're thinking in y equals mx plus b form, right? Y equals mx plus b, we know when x is 0, so it's 0 times m, which is just 0, we get a negative 2. Therefore, b has to be negative 2.
Mm-hmm.
Does that make sense? Yes or no?
Yeah.
Okay. And then it's just a question of finding the slope. I think that probably the easiest way, yeah, is still to graph it. But definitely the easiest way is to graph it, to calculate slope. If you could calculate rate of change another way, you can, if you're really comfortable with that. There's a way to calculate the slope mathematically. Change in y over the change in x. You can do that. I say graph it. Graph it. Any questions about number 25? We're good?
No.
Okay. All right. I think this is almost as complicated as function questions get. Let's look at the next one. Let's see. Ooh. Oh. Yeah, let's do this guy. We are at Nicole. You know, I'm going to go to Ava on this one just because she's had a little more experience with functions with me. Yeah, I'm going to go to Ava with this one if that's okay, because this is a new concept and it's kind of a tricky concept. Ava, go ahead and read question number 7 for me, please.
All right. The function f is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x?
Which of the following must be a factor of f of x? This is a very, very specific concept that they're testing you on. A very specific concept. It's not one we've discussed yet. Okay? Not at all. Let's go to the rules for mathing. Ava, can you read for me? This is the second bullet point. Read for me that second bullet point on functions.
For
Yep.
p, is that one?
Yep, for p of 3.
3 equals 0. X minus 3 must be a factor of p of x.
Okay, now stop. If p of 3 equals 0, x minus 3 must be a factor of p of x. Okay, that means if when you input a 3 for x and you get an output of 0, we know without a doubt that x minus 3 has to be a factor of f of x. Read the next part.
For p of negative 7 equals 0, x plus 7 must be a factor of
It
px.
has to be a factor of p of x. Okay, if we know if we plug in a negative 7 for x and we get a 0 as an output, x minus 7 has to be a factor of p of x. Let's go back to the whiteboard, and I'm going to explain why this is the case. Okay, I'm just going to make up a function out of thin air. Okay, not directly related to this one of the question. I'm just making up this function. And we'll say f of x equals, we'll do x plus 7 times x, I don't know, x minus 23. Okay? All right. And if I plug in a negative 7 for x, what's my output going to be when I plug in a negative 7 for x? What does this thing equal when x is negative 7?
0?
It's going to be 0. There's no way around it, right? Because I'm going to get negative 7 plus 7. That's going to be 0 right there. And 0 times anything is 0. So it doesn't even matter what the rest of the function is. It could be anything here. It could be x plus a billion or x minus a billion. It doesn't matter. It's going to be 0. Does that make sense? Why f of negative 7 is 0 in this case?
Yes.
Yeah? Okay. Now, again, I'm not saying that x minus 7 is the only, or x plus 7 is the only factor of this function. In fact, in this case, it's not. X minus 23 is another factor of this function. Now, we're talking about factors, by the way. We're talking about things that you multiply together to get some output, right? Factors are things, like the factors of 6 are 2 and 3, also 1 and 6, right? The parts that you multiply together to get some value, okay? So if you tell me that x minus 7 is gives you 0, I know x plus 7 is a factor of that function. All right. If you told me that, and I'm just going to make up another function. If you told me that that f of negative 3 equals 0. If you told me that, I'll make some space here on the screen. If you told me that, I know without a doubt that for the function f of x, I know that a factor is x plus 3. Does that make sense why? I know x plus 3 has to be a factor of f of x. Does that make sense? Because when I plug in a negative 3 for x, I get 0, right? It may not be the only factor. There may be another, x minus 27.4 may be another factor. I don't know. But I know at least a factor of a function. If f of negative 3 is 0, I know a factor is x plus 3. I'll give you one more example. I see this concept tested regularly. It's a high-level concept, but I see it quite a bit. If f of 5 gives you an output of 0, they tell you that. I know, without a doubt, that a factor of f of x is what? What does it have to be? A factor has to be what?
X minus 5?
X minus 5 has to be a factor. May not be the only factor. Another factor could be x plus 74.5. I don't know. There may be another factor. Another factor may be x plus 2. I don't know. But I know at least a factor is x minus 5 if f of 5 equals 0. Does that make some sense?
Yes.
Questions about that? No questions? This is a little bit tricky. If you don't fully understand, check out the recording of the video. We'll go over it again. Watch it a couple times. I think it will. Okay? And we still haven't even answered this question yet. So let's try to answer the question. I think it's going to make more sense when we answer the question.
Scroll back up to the numbers.
Yeah.
Yeah,
absolutely. Let's go there. I'm going to zoom in a little bit. Okay. And I'm going to clear some space on the whiteboard as well. Let's clear this. Okay. So let's read the question again. Now that we've kind of talked about this relation between inputs that give an output of 0 and the factors of a function. So read the question,
function
please.
f is defined by a polynomial. Some values of x and f of x are shown in the table above. Which of the following must be a factor of f of x?
Okay. So remember we said there are some inputs that give you an output of 0. And if we know which inputs give us an output of 0, we know what the factors are. What input gives us an output of 0?
The input of 4 gives us an output of 0.
The input of 4, oops, I'm on the erase function there. The input of 4 gives us an output of 0. So what's a factor have to be?
C.
It's got to be answer choice C, x minus 5. Or x minus 4, sorry. X minus 4, right? Which makes sense, right? Because if this is the function, f of x equals x minus 4, and it could be, again, x times anything, doesn't matter, right? When I plug in a 4, I have to get 0, because I get 4 minus 4. There's going to be 0. And 0 times anything, whatever that is, it's still going to give me 0. Questions about that? Does that make some sense? We're good? Okay, that's very tricky. Now, it's very tempting to go with answer choice B for this one, even if you understand this principle that we've just been discussing, right? B is very tempting, x minus 3. Because you look at this, you're like, well, when I plug in a 0, I get a 3 for f of x. But that's not what we're going for, right? I mean, we could even test it. That's what I would recommend doing, in fact. What's that?
I thought it might be that one at first.
Yeah, it's really tempting, but we could test it. Okay, let's say x minus 3 is a factor of f of x. So we'll do it. X minus 3 is a factor, and then some other function, whatever, or some other factor, doesn't matter what it is. And then let's plug in a 0 for x and see what the output is. And what do we get when we plug in a 0 for x? We get 0 minus 3, which is negative 3 times something. I mean, it doesn't tell me anything about the factors. Does that make sense? We're looking for the inputs that give us an output of 0 to find the factors. And the only input that gives me an output of 0 is 4. So the factor is x minus 4. Let's go back to the rules for math one more time. Let's take a look at that bullet point. I think this bullet point's going to make more sense. Ava, read it for me again, please.
A bullet point?
Yeah, for P of 3.
Oh, okay. P of 3 equals 0. X minus 3 must be a factor of Px.
Stop. Okay, stop. Does that make more sense now? If we know P of 3 gives us 0, an output of 0, x minus 3 has to be a factor. Does that make more sense now? Yes or no?
Yeah.
Yeah? Okay. And same thing, and the second one for P of negative 7?
For P minus 7 equals 0, x plus 7 must be a factor of Px.
Okay. So we know for some input of x, if it gives us an output of 0, we know the factors of the function. Just be aware of that principle, okay? If you're still stuck in it, doesn't quite make sense again, check out the video again, see if it makes sense after watching it a couple times. If not, don't freak out about it, because this is a really high-level difficulty question. And if you read a question, you're like, I don't even know what it's asking me, just skip it. Really, I strongly encourage you to. I tell my students you should be skipping about 10 questions on every SAT, depending on your skill level. But for the average student, at least 10 questions. At least 10 questions skipping that you read and you're like, I don't know what it means. Don't waste your time on it. You got to be spending your time on the ones you can get for sure. So if you're still
If you skip too many questions, can you get a low grade?
What's that?
If you skip too many questions, can you get a lower grade?
Well, let me put it in these terms. If you, let's say you skip 10 questions, okay? But then you're spending the rest of your time on all of the questions that you can get for sure, as long as you get to them, right? Let's say you nail the rest, okay? So you just get 10 wrong. And by the way, even in the 10 that you skip, you're likely to get at least 2 of them just because of, the odds, all right? Let's say you get 1 or 2, but let's say you get 10 wrong that or say you get 8 wrong from the 10 that you skipped, and then 2 others that you just messed up. So you get 10 wrong total, okay? Depending on the SAT, that could be between like a 670 and a 710. You could skip 10. You could get 10 questions wrong, get a 700 on the SAT math, easily, depending on the scoring scale. Would you guys take a 700 on the math out of 800? Would you take that? Yeah. You take that. Because you're getting 700 on the math, 700 on the verbal, you got a 1,400. We're talking scholarships and admissions to some elite schools. I mean, that 1,400 is excellent. Excellent. You're in the top 90 percentile, 97, 98 percentile. Excellent. Okay? Does that make sense? So we're not going for perfection here. We're not. So again, if you study this and you're like, I just don't quite get that concept, don't worry about it. Don't freak out about it. Watch the video a couple times, see if it registers. I suspect it will. But even if you read the question and you're just like, I don't know what's asking me, don't beat yourself up over it. Okay? But I'm going over all the advanced concepts that they do test you on, and they do want you to know this concept. I think we got one more function one. Functions are just huge, hugely important on the SAT. We've done this one already, of inputs and outputs. And most of us have done this one. Some of us from the level 1 course. Do you guys remember this one? I'm going to go over this, maybe not. I'm going to go over this real quick. Nicole, why don't you do this one for me? Read question number 10, please.
A function f satisfies f of 2 equals 3 and f of 3 equals 5. A function g satisfies g of 3 equals 2 and g of 5 equals 6. What is the value of f of g of 3?
Perfectly read. Beautiful. Okay. This looks really scary, right? Do you guys remember? Does anybody remember this one from the level 1 course? Maybe not. Some of you, I think we got this one, some not. So let's go over it real quick.
Oh yeah, I remember this one.
Remember? Yeah. It looks super scary, but it's not. It's not bad at all if you understand the relation between inputs and outputs. Again, all this is saying here is that when x is 2 for the function f, we get an output of 3. And when x is 3, we get an output of 5 for the function f. For the function g, when x is 3, we get an output of 2. For the function g, when x is 5, we get an output of 6. They're asking us, Nicole here, what's the value of f of g of 3? Looks scary, but we know what g of 3 is. What's g of 3?
2.
Yeah, g of 3 is 2. How do we know that? It tells us g of 3 equals 2. Right here. Right? So all they're asking us for is to solve for what? We're finding f of what?
F of 2.
F of 2, and what's f of 2?
3.
3. What's the answer choice?
This is my very, very favorite SAT problem.
I love it. Isn't it wonderful? Isn't it wonderful? It's B. Have you seen this one before, Nicole, or no?
I have not, actually.
Yeah. It's great if you understand the concepts, inputs, and outputs.
I think the first time I saw this in like the PSAT, I was like, "What is that?"
Yeah. It looks so complicated, but it's not.
Answer.
Again, they're not testing you on operations on the SAT. They're testing you on concepts. And whenever you see a function question, guys, whenever you see a function question on the SAT, you've got the rules for mathing. I've sent you. You've got this link, right? The rules for mathing. All of you have it.
Mhm.
Go over the function section. There's only 4 concepts they're going to test you on. Essentially, study it, use it while you're doing your own prep, and you'll get all the function questions. Questions about that?
No.
All right.
Nope.
Excellent.